Okay. All right. So I had some audio issues a second ago. So I'm restarting the stream, and what we're going over in this stream is managing growing projects with packages, crates, and modules. So this is the 7th chapter in the book. Also, if you guys could put something in the chat to let me know if the audio is good this time around, that would be appreciated. But yeah, we're going to be going over chapter 7, I guess kind of how to architect our projects here and things like that. Also, I have this chat thing. I think I have audio's good. Okay, nice. I think for some reason it works with Twitch and Discord. So like also like I'll be able to get the Discord chat in here as well. But for some reason YouTube doesn't seem to be behaving very well. I don't know what the problem is. I'm gonna have to sort that out later. But yeah, in the future I'm gonna be able to stream, and then we'll be able to do chats on Discord and all as well. Anyway, until then, let me grab this pop-out chat. There is... One second. There is a link in the description of like every single video for the Discord. So you should be able to find it there. So I'll put that there for now. In the future, you'll be able to talk through Discord, and then we can do restream and all this kind of cool stuff where YouTube, Discord, and Twitch will all have the same chat. But for now, this is what we're doing. All right, so let's get started with the chapter, Managing Growing Projects with Packages, Crates, and Modules. Now, I'm going into this pretty much cold. I don't really know what any of this stuff is. I think that's what's mostly useful, is that I'm kind of learning this stuff, and then when I have my aha moments and I understand what something is, then hopefully it's a little bit, it becomes a little bit more intuitive that way, I guess. All right, so let's get started here. What font am I at? Yeah, that's fine. Okay, as you write large programs, organizing your code will be important because keeping track of your entire program in your head will become impossible. By grouping related functionality and separating code with distinct features, you'll clarify where to find code that implements a particular feature and where to go to change how a feature works. Right, so you should structure your code better than everything just in one file or something like that. Okay, so the programs we've created so far have been in one module in one file. All right, so like if you've been following along with the book, we had like a guessing game and like all the other kinds of stuff that we did. It's always just been one file. A package can contain, okay, one second. As a project grows, you can organize code by splitting it into multiple modules and then multiple files. So I guess, can you have multiple modules in one file, or I don't know. So a package can contain multiple binary crates. And a binary crate is just like a runnable thing inside of a crate. Like, I don't know, what's something that I've cargo installed before. If I can think of something, then I'll write it out. But I think actually ripgrep you can install with cargo. So for instance, like ripgrep, which is actually RG, you can install that with cargo, right? And it's a binary. Actually, I think where you can find your binaries is in .cargo and then in bin. And these are all binaries. Binaries are things that you can run on your system. So if you don't know what a binary is, all these things are like commands that I can run from my terminal. And so these are all binaries, right? So yeah. Let me also put this on live chat because, oh, there we go. That's always the case. I'm on top chat. Thank you, Safari Night. How's it going, Victor? Thank you for streaming earlier. Oh, what? The stream I did 1 second ago with the failing audio? Anyway, so a package can contain multiple binary crates and optionally one library crate. Let me see. So a package can contain multiple... 1 second. I need to check something really quick. Content, yeah. All right. Yeah. Okay, we're on the right thing. All right, so a package can contain multiple binary crates and optionally one library crate. So you can have one library crate and multiple different binaries inside of what, a package? All right, so packages contain crates. What is a crate in this concept? Modules, I'm just kind of scoping to files at this point. All right, so as a package grows, you can extract parts into separate crates that become external dependencies. This chapter covers all these techniques for very large projects of a set of interrelated packages that evolve together. Cargo provides workspaces, which we'll cover in Cargo Workspaces section, chapter 14. All right. So in addition to grouping functionality, encapsulating implementation details lets you reuse code at a higher level once you've implemented an operation. Other code can call that code via the code's public interface without knowing how the implementation works, right? So this is just so, it's like the dry principle. So if you've never heard of the dry principle, it's don't repeat yourself, right? So we don't want to repeat ourselves. We want reusable modules. That's basically why we want to do this. The way you write code defines which parts of... let's see. Streaming earlier in the day? I don't think I did stream earlier in the day, did I? I think my computer's been off pretty much all day. Anyway, so unless some ghost showed up to my computer. All right, the way you write code defines which parts are public for other code to use and which parts are private implementation details that you reserve the right to change. All right, so this is another way to limit the amount of detail you have to keep in your head. Oh, the time of day. Okay, so you're glad that I'm streaming earlier today. I got you. No, your English is fine. I think I just read it wrong. Okay. I'm like, did I stream earlier today? And I just forgot about it. I was like, I've been working all day. Anyway, so this is another way to limit the amount of detail you have to keep in your head. Yeah. Okay, this is simple stuff. A related concept is scope. The nested context in which code is written has a set of names that are defined as in scope. Okay. When reading, writing, and compiling code, programmers and compilers need to know whether a particular name at a particular spot refers to a variable, function, struct, enum, module, constant, or other item, and what that item means. You can create scopes and change which names are in and out of scope. You can't have two items with the same name in the same scope. Tools are available to resolve name conflicts. Okay. So let's see here. Rust has a number of features that allow you to manage your code's organization, including which details are exposed, which details are private, and what names are in each scope in your programs. Okay. So these features sometimes collectively referred to as the module system. Okay, so this is the module system. So we refer to these four things as to be inside the module system, and they include packages, a cargo feature that lets you build, test, and share crates. Okay, so we can package up, so we can build, test, and share crates. That's what packages are in this module system context, I guess. Crates, a tree of modules that produces a library or executable. Modules and use let you control the organization scope and privacy of paths. Paths, a way of naming an item such as a struct, function, or module. Okay. In this chapter, we'll cover all these features, discuss how they interact, and explain how to use them to manage scope. By the end, you should have a solid understanding of the module system and be able to work with scopes like a pro. I certainly hope so, because already I'm a tad bit confused by this. All right. Good luck. I'm also on my way to learn Rustlang. That's good. Rust. The reason that it's nice to learn Rust right now is just because it's a low-level programming language that is popular. So a lot of people want to learn it, and I feel like that doesn't happen very often. So I want to jump on that while it's still interesting, I guess. Hey Chris, no face cam today? Nah, not today. I hate the e-boy face cam stuff. I'll turn it on sometimes, but not all the time. Do you have a goal in mind for what you're looking to build with Rust? I have two ideas that I want to work with Rust, and it's nice because one of them is a CLI program, and the other one is a web server. So one for the CLI program is a I want to make this. I have a couple ideas. I'd also like to potentially help work on this thing over here, but I don't think that this is super complicated. But there's one thing I wanted to make for color schemes with NeoVim. I wanted to make an executable, because right now if I want to create a color scheme, I have to use this like Python thing, which is nice. The script is nice, but I want to use a TOML file where I just say like, okay, here's all the highlight groups, give the highlight groups values, and then I just want to run like, all right, generate a color scheme, call it this, boom, create me all the files, and then just publish it out. So that's one thing I wanted to create with Rust. The other thing I want to make is a web server. Now, obviously, I could do these things with Python, and I could do, you know, whatever. I could make a web server with Python or Go or something like that, right? But I want to learn Rust, so that's why I'm making these things with Rust. Now, the web server, I want it to be able to get an Atom XML feed, and I want, whenever I publish a YouTube video, I basically just want it to tweet it out on my account or any other social medias. That way I can scale my social media presence, right? So like I could like post it out to Mastodon or Twitter or whatever other social media stuff exists out there. So that's like a web server that I wanted to build, which is nice because they have at the end here, chapter 20, building a multi-threaded web server. So that's kind of, those are a couple things I want to make. Does that make us Rustaceans? I don't know. I don't like the term Rustation person. I don't call myself like a Java thing. I just call myself a Java developer or something like that. Developer who knows Java. I don't know. Yeah, same. People are building more than just system dev tools with it. Web stuff, linear algebra modules, even some data science. Yeah, it's in. Oh, and the other third reason that I wanted to learn it is because it's all entwined in the blockchain space. So like Lightning node implementations are written in Rust. A lot of scam coins are written in Rust. All kinds of stuff in blockchain world is written in Rust. So I think that's also interesting. There's also the concept of, I don't know really anything about WebAssembly, and I know Rust has some place in that. So I figured, you know, I would sort that out and figure out what's even going on with WebAssembly, because I have no clue. Cargo isn't a Rust packager these days as it is a systems package manager. In a way, yeah, it's kind of like pip or npm though. Like I have some programs like programs I have installed, I installed with npm or pip. Whole paradigm of ownership is very interesting coming from other languages. Yeah, it's definitely pretty neat. I don't have a Mastodon. I plan to get one in the future. Are you going to deploy these features to serverless functions? Yeah, I think I actually, that was kind of the plan for the web server, was to deploy it on something like, well, really, I don't know. I think Supabase could do it, so I was thinking about maybe using Supabase, and then maybe I could even spin up my own server with it. But, you know, something like AWS Lambda in a sense, right? That was kind of my plan. Rust is not particularly fond of that fact, but they do not disregard it entirely. Oh, the crypto stuff? Yeah. Yeah, it's a programming language. The programming language doesn't care what it's used to create, right? So I'm not really worried about it. But the stuff that I really like when it comes to the crypto stuff is the Lightning Network stuff. That's what I'm interested in. I'm interested on layer 2s for projects that make sense. Things like Bitcoin, things like Monero. The scam coin stuff is really nice to like experiment with, but it's also a great place to lose your money or make a ton of money in a casino-like space, right? People thinking it's anything really more than that, or like, you know, they're a little crazy. Anyway, we gotta go through here. So first parts of the module system will cover our packages and crates. A package is one or more crates that provides a set of functionality. A package contains a cargo.toml and a file, which is a file that describes how to build those crates. All right. Right. A crate can be a binary crate or a library crate, right? So that makes sense. These are binary crates. Library crates are things like, for instance, like, okay, you know, Rust C is like a binary crate. Clippy driver is a binary crate. Cargo format is a binary crate. Cargo Clippy is one, right? RG is would be another one. So these are binary crates. Now, a library crate would be something like if we go into the Rust book here and we open up guessing game and we take a look at this here. This is a library crate. So something like Rand is a library crate. And this was the thing I wanted to show you, is I have like completion that shows me all the old versions, right? So I could like go back to 8 and see like whatever. It looks like this one's been yanked and like taken out. So like apparently that one probably had bugs or whatever. And then also if I go to like this here, so if I have like RAND 0.7, whatever, it's going to let me know like, hey, you have an upgraded version that you could do. And so I'll do space LA. And then you can see over here, if I just, let me see if I can, well, let me move this out of the way. So I'll do space LA like this. And I can do open crates.io, so I can enter that, and I can go see this crate on crates.io. Or I could do space LA. I can open up the documentation for the crate, right? We got update all crates, so I can do that. It'll update it to the latest version of, I guess, 7 or whatever. In this case, upgrade will upgrade the biggest bump that it can, right? So like everybody's on 0 ver these days. So, you know, there you go. There's an upgrade. And that's pretty much everything right there. Yeah. So I really like this as a crates.nvim plugin. It's really neat. It helps me work with these crates. Now, where did I go? Okay. It's called crates.nvim. Crates.nvim. Let's see if I can pull it up. Crates.nvim. Yeah. This thing. Let's check it out. It's very cool. I got another new plugin recently too, where I can do space B and then browse, and then I can go through, like, for instance, my bookmarks. One of them is Awesome NeoVim, so I can just click on Awesome NeoVim, and then I know Crates is in here. So if you go to Awesome NeoVim and you search for like things like Rust related, you will find Rust tools, and then you'll find crates.nvim. That's where I found this thing anyway. All right, so let's, again, I wanted to show that off, but let's kind of get through. We got to get through some of this stuff, right? Crate can be a binary crate or library crate, so we went over what the difference was. Binary crates are programs you can compile into an executable that you can run, such as command line program or server. They must have a function called main that defines what happens when the executable runs. All the crates we've created so far have been binary crates. Really? Yeah, I guess they have been in a way, because we've been running them. Library crates don't have a main function, and they don't compile to an executable. They define functionality intended to be shared with multiple projects. For example, the RAND crate we used in Chapter 2 provides and that's this guy here, provides functionality that generates random numbers. The crate root is a source file that the Rust compiler starts from and makes up the root module of your crate. Okay, wait. The crate root is the source file that the Rust compiler starts from and makes up the root module of your crate. We'll explain modules in depth, I guess, later on in this section. All right, several rules. I guess the crate root in this case is what? Just right here, I guess? I don't know. Several rules determine what a package can contain. A package can contain at most one library crate. It can contain as many binary crates as you like, but it must contain at least one crate, either library or binary. Okay, let's walk through what happens when we create a package. First, we enter the command cargo. Well, I don't really need to type this out. We can see it right here. So we create a new project. It created binary my project, and then we can see inside of it we got the cargo.toml, a source directory, and inside the source directory is the main.rs. So actually, we're basically looking at pretty much the same structure right here, right? It also actually puts a git ignore too. I guess they're just ignoring that, and also a cargo lock, but you can probably safely ignore those two files. All right, so when we entered the command cargo created a cargo.toml file, giving us a package. Looking at the contents of cargo.toml, there is no mention of source main rs because cargo follows a convention that source main rs is the crate root of a binary crate with the same name as the package. One second. Looking at the contents of that, there's no mention of blah, blah, blah. What do you mean there's no mention? I guess when we create it, there's no mention. Cargo follows a convention is the crate root of the binary with the same name as the package. Okay. Oh, okay. It's like init.lua or, yeah, okay. I get it, I think. So likewise, cargo knows that if the package directory contains source lib.rs, the package contains a library crate with the same name as the package, and source lib.rs is its root crate. Cargo passes the crate root files to the Rust compiler to build the library or binary. Okay. So if we wanted to create a library instead of main.rs, we'd have like lib.rs there. Here we have a package that only contains source main.rs, meaning it only contains a binary crate named my project. If a package contains source main.rs and librs, it has two crates, binary and a library, both with the same name as the package. A package can have multiple binary crates by placing files in the source bin directory. Each file will be a separate binary crate. Okay, I got you. Defining modules to control scope and privacy. In this section, we'll talk about modules and other parts of the module system, namely paths that allow you to name items, the use keyword that brings a path into scope, and the pub keyword to make items public. We'll also discuss the as keyword, external packages, and the glob operator. Okay, so I'm familiar with the as keyword from something like Python. The use keyword is, I guess, just like the import keyword or whatever. And then pub is, I guess, going to give us the ability to use what would be, I'm assuming, private members by default in modules in other modules. All right, so first we're going to start with a list of rules for easy reference when you're organizing your code in the future. Then we'll explain each of these rules in detail. All right. Module quick reference. Here's how modules paths, the use keyword, and the pub keyword work in the compiler, and how most developers organize their code. We'll be going through examples of each of these rules, but this is a great place to look in the future as a reminder of how modules work. All right, start from the crate root. When compiling a crate, the compiler first looks in the crate root file, usually source librs for a library crate or source main.rs. Okay, so this is the crate root. All right, declaring modules. In the crate root file, you can declare a new module named, say, garden, mod garden, I guess at the top. And the compiler will look for the code inside the module in these places. In the line directly following mod garden within curly braces instead of a semicolon of the semicolon. In the file garden, okay, so in the file garden.rs, or in the file source garden mod.rs. Okay, and where mod stands for module. All right, declaring submodules. In any file other than the crate root that's being compiled as part of the crate, for example, source garden rs, you can declare submodules. For example, mod vegetables. Okay, part of the crate. Okay, so if we were in garden.rs, which is a module, we could create a submodule called mod vegetables at the top. All right. The compiler will look for the code inside submodules in these places within a directory name for the parent module. All right, so in line, in this file, under garden, the directory garden, if you chose not to just call it garden, or in garden vegetables mod rs. All right. Pass the code in modules. Once a module is being compiled as part of your crate, you can refer to code in that module. For example, an asparagus type in the garden vegetables module from anywhere else in this crate by using the path. Okay. Using the path crate garden vegetable. All right, gotcha. As long as the privacy rules allow. Private versus public. Code within a module is private from its parent modules by default. To make a module public, declare it with pub mod. Okay, that's simple. The use keyword. Within a scope, the use keyword creates shortcuts to items to reduce repetition of long paths in any scope that can refer to. All right, so this you can create a shortcut with use. One second. Use keyword. Within a scope, the use keyword creates shortcuts to items to reduce repetition of long paths. In any scope, you can refer to this thing. You can create a shortcut with use, and then you only need to write asparagus. Right, okay. That's simple. Here's a binary crate named backyard that illustrates these rules. The crates directory, also named backyard, contains these files and directories. Okay, so we have a file or folder named backyard. So we name the entire thing backyard. So this one's name is guessing game, this one's name is backyard. Then we have the cargo lock and the cargo toml. Under that we have our source directory, just like that there. Under that we have a module called garden, which this is the module called garden. And then this is a submodule path for vegetables.rs. And then this is the root, the crate root, right? Or basically the root module. And so this will contain this stuff here. I mean, we could probably write this out. So we could do cargo, and then new, and then back yard. And we'll open up backyard, and then we'll go into the main. All right. Let's see. Is that from Rust Analyzer into LSP? Actually, it's just from crates.nvim. If you're talking about that stuff, so there's nothing really there. There's no LSP Rust Analyzer stuff that you need. You can compile Rust to WebAssembly and communicate with Rust and other languages via bridge with JavaScript and TypeScript. Lets you do some neat stuff. Yeah, that sounds interesting. That's where I'd like to get to, is this place. What's the plugin? I think I went over that. Did you hear about Rust getting a place in the kernel? Yeah, I don't know. I guess. I don't know how I feel about that. I mean, look, Rust is a great language and all, but I don't like this. This is the part about Rust that I personally don't like, which is just this culty aspect and forcing Rust into every single situation and scenario. Create fantasy movie and make it real later. I don't know. Maybe I missed that. Okay, so now we have our main function here. And so right now we're trying to use a crate, garden, vegetables, asparagus, and we're gonna, I guess, make some module public, the garden module? I don't know. Well, I guess we'll find out. So the pub mod garden means the compiler includes the code it finds in source garden RS. Okay, so that's all that means. It just includes that. File names, source garden RS. Is that all that's in there right now? Source garden RS. So let's we can open this up. We can create source, and then we got garden, and we'll I guess make that for now. And then what goes under that? Oh wait, no, it was under. Well, there is that, but let's get rid of that for now. We want garden.rs. Okay. And inside of here, we have this there, I guess, like that. Pub mod vegetables, because we have public module garden in here, and here we're going to have public module vegetables. And pub mod vegetables means the code in source garden vegetables.rs is included too. So let's make that. So we're going to do garden. Okay, and then we're going to, whoops, and then we're going to do vegetables.rs. Whoops, that's in the wrong spot. Rename to, and we're going to put garden like that. Okay. That should fix all of our bugs, right? Yeah, so all of our bugs are fixed now. Can I please increment the font a little bit? Yeah, sure. Is that better? Would love to see you an Actix tutorial from you. Well, once we get there. First, we got to get there. What terminal am I on? I think right now, Kitty. Yeah. All right. So now we got all this stuff working. All right, now let's get into the details of these rules and demonstrate them in action. Grouping related code in modules. Modules let us organize code within a crate into groups for readability and easy reuse. Modules also control the privacy of items, which is whether an item can be used by outside code, public, or is an internal implementation detail and not available for outside use, private. Okay. Sure. As an example, let's write a library crate that provides the functionality of a restaurant. Okay, now I gotta redo a whole new thing for restaurant, but this was at least somewhat instructive. Okay, so library crate that provides the functionality of a restaurant. We'll define the signatures of functions, but leave their bodies empty to concentrate on the organization of the code rather than the actual implementation of a restaurant in code. Okay. In the restaurant industry, some parts of a restaurant are referred to as the front of the house and others as back of house. Front of house is where customers are. This is where hosts seat customers, servers take orders and payments, and bartenders make drinks. Back of house is where the chefs and cooks work in the kitchen, dishwashers clean up, and managers do administrative work. Structure our crate in the same way that a real restaurant works. We can organize the functions into nested modules, create a new library named restaurant by running blah, blah, blah. All right, so we can pass the lib flag, it looks like, to create a library. All right, so we're going to do cargo, new, lit. I don't know why I wrote live. Can't type. There we go. Lib. And then what is it? Restaurant is a hard word to spell. Restaurant, like that. Yeah. Okay. All right, so now they give us a lib.rs, and it looks like we got some tests here. And we got some other stuff. So yeah, okay. But we're gonna replace that. Now notice we don't have a main function. And so we just have a couple functions that are never used. So we have add to waitlist, seat at table, take order, serve order, and take payment. We define a module by starting with the mod keyword. Okay, so this is a module. And so this is kind of like an inline module, I guess, and this is a sub-module. So, okay, we define a module by starting with the mod keyword and then specifying the name of the module. In this case, front of house and place curly brackets. Wait, what? In this case, front of house. Okay, so front of house is our module. And place curly brackets around the body of the module. Inside the module, we have other modules, as in this case with the module hosting and serving. So we have hosting and we have serving. Modules can also hold definitions for other items, such as structs, enums, constants, traits, or as in listing 7-1 functions. Okay, so we can hold other definitions for other items, structs, enums, constants, traits. Okay, we haven't really gone over traits yet, but sure. By using modules, we can group related definitions together and name why they're related. Programmers using this code would have an easier time finding definitions they wanted to use because they could navigate the code based on the groups rather than having to read through all the definitions. Programmers adding new functionality to this code would know where to place the code to keep the program organized. Earlier, we mentioned that main.rs and lib.rs are called crate roots. The reason for their name is that the contents of either of these two files form a module named a crate at the root of the crate's module structure known as the module tree. All right, so this is our module tree. Okay. So yeah, so this isn't even a file tree right now. This is just how the modules are really like laid out. So we have our crate. It has the first top module called front of house, then hosting, and that's the same as here, and then the stuff we do. All right, I got it. Let's see. 1 second. I have a train that's coming by. Hopefully it doesn't make the train whistle noise. All right, so this tree shows how, there it goes. Okay, hopefully that's enough. This tree shows how some of the modules nest inside one another. For example, hosting nests inside a front of house. Right, exactly. I have barking dogs. I have trains that go by out front. Speeding motorcycles. We have it all here. So the tree also shows that some modules are siblings to each other, meaning they're defined. Can I make the font size bigger? That's about as big as I probably can make it without it being like crazy. And then over here, I don't know. I mean, maybe I could do that. The tree also shows that some modules are siblings to each other. So this is a sibling module, hosting and serving. To continue the family metaphor, if module A is contained inside of module B, we say that module A is the child of module B. And sure, okay, I got that. Module tree might remind you of a file system directory tree on your computer. This is a very apt comparison. Just like directories in a file system, you use modules to organize your code, and just like files in a directory, we need a way to find our modules. Okay, got it. Got it. All right, so now we have 7.3, 7.4, and 7.5. All right, this is going to be a little longer, I guess. All right, so paths for referring to an item in the module tree. To show Rust where to find an item in a module tree, we use a path in the same way we use a path when navigating a file system. If we want to call a function, we need to know its path. Gotcha. A path can take two forms: an absolute path, starting from the crate root I think we saw that earlier, by using a crate name for code from an external crate, or a literal crate for code from the current crate, right? A relative path starts from the current module and uses self, super, or an identifier in the current module. Both absolute and... Okay, so wait, you put this if you define that same crate in your same project. All right. A relative path starts from the current module and uses... Yeah, I got that. Both absolute and relative paths are followed by one or more identifiers separated by double colons. Okay. Let's return to the example in 7-1. How do we call the add to waitlist function? This is the same as asking, what's the path of the add to waitlist function? Listing 7-3 contains listing 7-1 with some of the modules and functions removed. So this is 7.3. Okay. We'll show two ways to call the add to waitlist function from a new function at eat at restaurant. Okay, so this is eat at restaurant, and we want to call add to waitlist, but this is a function that is, the module is local to us, but this is a submodule. So we want to call this submodule inside of this public function here. All right. Let's see. Do they say anything too groundbreaking here? The eat at restaurant function is part of our library crates public API. So this is part of the public API because it's public. This is private by default, so it's not available. What's this say? Hey Chris, great job on your videos. You really helped me with my new Vim config, and you're doing another interesting subject. Thanks. All the best. Thanks. Let's see here. So in exposing paths with the pub keyword section, we'll go over more detail about pub. Note that this example won't compile just yet. We'll explain why in a little bit. Well, let's find out why it won't compile, because we'll see. And the reason is hosting is private. Okay, what if I tried to do that? And then this is also private. Now, so for instance, if we had a function in here, maybe in some other module in here, I don't know, maybe even in here. Let's see, can I save that? So now hosting is okay, but add to waitlist is not okay, right? And then front of house, this isn't going to work because we're inside here, so that's like relative. So now it's like, all right, I found hosting because that's not, that's not a problem, but that's not the case. Now, if I made this public, that would fix that. Now we still have our hosting problem. I can make this public like that, and that's going to fix pretty much everything. So now I don't know if there's a better way, but that's the way that I initially thought to do it. So there's our problems. That's how I would fix them right now. All right. Calling the add to waitlist function using blah, blah, blah. First time we call the add to waitlist function there, we use an absolute path. Yeah, I think we get that. After the crate, we include each successive module until we make our way to the waitlist. Yeah. I think we get it. Right. So I guess this is the part that is probably going to be a little bit different, which is starting from crate, right? So starting from crate starts from where does that start from? Because I think that's going to be the only real interesting part here. I think this one is pretty you get it, right? We have front of house. It's local here. It's fine. Then you would expect you'd be able to get hosting because it's right there, and then add to waitlist. But this crate thing is kind of a little bit different. After, let's see, so function is defined in the same crate as eat at restaurant, which means we can use the crate keyword to start an absolute path, right? So this function is defined in the same overall crate where the crate is restaurant. So that's how come we can use this. We wouldn't be able to use this had we been grabbing some of this stuff from an external crate that we pulled in as a library. All right, so after crate, we include each of the successive modules until we make our way to add waitlist. can imagine a file system, and crate is like the root of the file system. Okay. Yeah, we call it. That's relative. Pretty simple. Obviously, we just drop the crate because we have it's available to us here. Choosing whether to use a relative or absolute path is a decision you'll make based on your project. Whether you're more likely to move an item. Okay, the decision should depend on whether you're more likely to move an item item definition code separately from or together with the code that uses the item. For example, if we move front of house module and the eat at rest function into a module named customer experience, we need to update the absolute path to add waitlist. Right. Okay. And if we just do it like relatively, then we won't have that problem, I guess. All right, so there's trade-offs. I'm sure we'll run into them. Let's try compiling 7-3 and find out why it won't compile yet. We already know why it won't compile because we don't have access here or here, right? The error messages say that the module hosting is private. In other words, we have the correct paths for hosting module and the add to waitlist function, but Rust won't let us use them because it doesn't have access to the private sections. All right, so modules aren't useful only for organizing your code. They also define Rust's privacy boundary, the line that encapsulates the implementation details external code isn't allowed to know about, call, or rely on. So we have to kind of expose like an API of this module. So this module needs to expose something about it, some way to interact with it. Right now, this module is completely hidden. So in the case right now, it would only be useful inside of front of house, right? So if you want to make an item like a function or a struct private, you put it in a module. All right. The way privacy works in Rust is that all items, functions, methods, structs, enums, modules, and constants are private by default. Items in a parent module can't use the private items inside child modules, but items in child modules can use the items in their ancestor modules. Okay. The reason the child modules wrap and hide their implementation details, but the child modules can see the context in which they're defined. To continue with the restaurant metaphor, think of privacy rules as being like a back office of a restaurant. What goes on in there is private to the restaurant customers, but office managers can see and do everything in the restaurant in which they operate. Fair enough. How's it going, Bailey? So let's see. Rust chose to have the module system function this way so that hiding inner implementation details is the default. That way you know which parts of the inner code you can change without breaking outer code. But you can expose inner parts of the child modules code to outer ancestor modules by using the pub keyword to make an item public. All right. Exposing paths with the pub keyword. That's what we're going to do here. So why don't we just take this and go like this. All right, so that's kind of what we did earlier. We put pub in front of it, and now we can notice that hosting is now public to us, and there you go. But we still have a problem with this function, which is still private to this hosting module. Okay, and what are they going to do? The same thing as we did before, so we'll just take this code again. Boom, and there you go. I don't know what this is complaining about. I think that's complaining about nothing, though. Okay. Adding the pub keyword to, yep, we got that. Now compiles. In the absolute path, we start with the crate root system, then the front of house module defined in the crate root. The front of house module is in public, but the eat at restaurant function is defined in the same project. Yeah, I think we get it there. So here's maybe something. If you plan on sharing your library crate so that other projects can use your code, your public API is your contract with users. Yeah. It's just simple, right? Like, you need to have some stuff be public so that it can be used. The stuff that's public is the public API. It's the things that you want to do. Everything else is just private business logic that nobody cares about. This is pretty standard basic stuff, right? Let's see. So it looks like there are API guidelines. So maybe that might be useful one day to look into. Oh, this is like a book in and of itself. Maybe I'll go over that in the future. Let's put this inside the Rust one, and then we'll do Rust API guide. I keep finding all these other little Rust books that are available out there. Like if you look, if I go into the Rust thing here, there's a Rust Up book. There is another book called Rust by Example. And I just keep collecting them. Async programming in Rust, which is still being worked on. It's got some to-dos in there. I was thinking about going over that later. What else do we got? And now we got the Rust API guidelines. So there's these other little books that aren't part of like the main book. How's it going, Slavka and Sasha? 1 second. We mentioned a package can contain both that. Yeah, I might as well read this, I guess, because it's in purple. We mentioned a package can contain both a main RS binary crate root as well as a library crate root, and both crates will have the package name by default. Typically, packages with this pattern will have just enough code in the binary crate to start an executable that calls code with the library crate. This lets other projects benefit from the most functionality that the package provides because the library crate's code can be shared. Okay, the module tree should be defined in this. Then any public items can be used in the binary crate by starting paths with the name of the package. The binary crate becomes a user of the library crate, just like a completely external crate would use the library crate. It can only use the public API. This helps you design a good API. Right, okay. So it makes sense. So the library crate exposes some public API, and the binary that's associated with it in that crate can only use what the library provides. So if you wanted to create another binary that uses this library, you'll have good API design for that library because you already created a binary that uses the exposed functionality from this library. If that makes any sense. It might not make sense. It's not super important, but I do think I understand what's going on with this. In 12, we'll demonstrate this organizational practice with the command line program. Yeah, that's what I'm looking forward to. Okay, so now we got relative commands with super. Bridges 369, how's it going? I'm from Brazil. Say hi, please. Hi. I admire you a lot. Thank you. All right, so starting relative paths with super. We can also construct relative paths that begin in the parent module by using super at the start of the paths. This is like starting a file system path with the ... syntax. Why would we want to do this? All right, let's see. So consider the code in listing 7-8 that models the situation in which a chef fixes an incorrect order and personally brings it out to the customer. The function fix incorrect order defined in the back of house module calls the function deliver order defined in the parent module by specifying the path to deliver order starting with super. Let's maybe get some of this stuff here. So it looks like we're okay. Okay. So now we're inside of a module context. We're in a function inside that module context, right? In this module context, we have a function called cook order. And then this guy out here, we know nothing about him because he's not in the module, so we know nothing at all about that. So if we get rid of the super like this, cannot find function deliver order in this scope, not found in the scope. So it's just not in the scope. But we can go and cherry pick it from some outer scope, just one level out, with the super. So I'm assuming this doesn't go like 2 levels out or anything like that. That's what I'm assuming at least. All right, so the fix incorrect order function is in the back of house module. We can use the super to go back to the parent module of back of house, which in this case is crate. So this actually is crate. Like this is, if we were in crate, well, like we're in crate right now, and crate would have, we'd be able to do like crate yeah, there you go, back of house, right? Like that's literally where we are right now. And so this deliver order is in crate. And so super is looking like this. Like if crate is equal to the root, like so crate is root, and let's see, back of house is back of house, right? And then that would be equal to crate, crate back of house, right? So that's like that. That's not really the best way of thinking about it. Let me see if I can like make this. Actually, yeah, that's basically is the way that I'm kind of thinking about it. Like if we expand crate, then it becomes crate slash back of house, right? And then inside of that are like different methods and stuff. So if you were in back of house, so if you're in back of house, then if you, it's just like cd ... right? So if you do, let's see here, if we do like cd ... from back of house, it would go back to crate, and then it would be able to do stuff there, right? So it's the same as like if you're like doing something and you're like in some context and you're like move thing ... slash that, or we'll name it like .txt. That would name that would move the thing.txt file back one directory. And so here we're just referencing back one module context. All right, that's pretty simple. And super is nice as a word here, just because I'm used to super from like Java and stuff. So it just also makes sense to me from that perspective. All right, so making structs and enums public. We can also use pub to designate structs and enums as public, but there are a few extra details. Actually, I'm just curious really fast. If we do this like that, and then, well, no, even if this is public, it still won't work because it has no context. Yeah, it's just not in the scope at all. Okay. We can make each field public. Okay, here we go. Making structs and enums public. We can also use pub to designate structs and enums as public, but there are a few extra details. If we use pub before a struct definition, we make the struct public, but the struct's fields will still be private. Right, but then we could write an impl on it, and then we could write getters and setters. We can make each field public or not on a case-by-case basis, right? In listing 7-9, we defined a public back of house breakfast struct with a public toast field, but a private seasonal fruit field. This models the case in a restaurant where the customer can pick the type of bread that comes with a meal, but the chef decides which fruit accompanies the meal based on what's in season. Okay, yeah, this is we can understand that. All right. So what you can do, all right, so we're going to eat at the restaurant, and we're going to make a mutable meal here. And the way that we're going to construct our meal is we're going to say, okay, from the back of the house, so this thing here, then we got breakfast. So we want breakfast. We're going to get it from the back of the house. And in the summer, I guess, summer's a function on this thing. Then we're going to choose rye, I guess, which is like some kind of toast, right? And then we're going to say meal.toast equals string from wheat. So this is meal.toast. Let me see. I'm a little confused by this. So we have this summer function here. Are you changing it? Was it initially rye? And then you changed it to wheat? I guess, I don't know. So I'd like blah toast, please. And then that's meal.toast. I didn't even read the comments here. Order breakfast in the summer with rye toast. Change our minds. Right. Okay. Yeah. The next line will compile if we uncomment it, if we're not allowed to. Modify the seasonal fruit that comes with the meal. Okay, so yeah, this is just a modification. Yeah. I was like, because this is stupid to do, right? Like doing this and then just immediately changing it. So I guess that's what confused me, because I'm looking at it like, why even do this if you just defined it with rye like a second ago? But that's because that's like the point, that we're proving that we can change this. But we're also proving that we can change the seasonal fruit here because you can see that we have public, toast is public, but seasonal fruit is private. So if we made it public, then it would be fine. We get rid of that. We're not fine if we got rid of public for toast, then we also can't do that. All right. Because the toast field, yeah, we went over this kind of. Also note that because back-of-house breakfast has a private field, the struct needs to provide a public associated function that constructs an instance of breakfast. We've named it summer here. If breakfast didn't have such a function, we couldn't create an instance of breakfast. Wait, why not? Note that because back-of-house breakfast has a private field. Oh, yeah. This private field, we can never construct this. Like, we could never ever just construct this thing because it has this seasonal fruit aspect in it. So because it has the seasonal fruit field in it, we're not able to construct this on our own. We need a helper method which will let us do that because the method here has access to be able to change the seasonal fruit because, let's see, the reason is because this is public. This is implemented on, because this is an implementation on the breakfast struct. So it has access to everything inside of the breakfast struct. We went over that earlier in the implementations and methods section. O and RD. All right, sounds good. Hey there, I just started to approach Rust. That's good. Well, me too. I'm getting pretty far, though. I'm on chapter 7 of the book. And then when I'm done with chapter 7, we'll see where I go from there. Or, well, done with at least chapter... I'd like to get to chapter about 12 to get that command line app going. Okay. So, okay, we get this. We understand how that works. In contrast... oh, wait. Yeah. Okay. In contrast, if we make an enum public, all of its variants are then public. We only need the pub before the enum keyword. Okay. So putting pub before a struct, you still need to make its fields public. So this behaves a lot more like a class kind of, I guess, in Java. And in this enum, everything is just public as soon as you say the top level is public. So let's do that. So we have back of house, public enum, appetizer. These are already public by default. You don't have to, and you probably can't even put pub in front of them, right? So yeah, so they're just public by default, and we have access to everything that we want. All right, so because we made the appetizer enum public, we can use the soup and salad variants and eat at restaurant. Enums aren't very useful unless their variants are public. It would be annoying to have to annotate them all. Yeah, this makes sense. I'm not sure, but maybe you can do breakfast toast. All right, hold up. If breakfast implements derives the default trait. Oh, so you're saying, yeah, but what would it be in the default case, right? Like if I did do this, right? I'd also need to put the trait on it. And also this thing doesn't want to behave with me right now. Yeah, so I would need to put the trait on it. I almost forget how to put traits on things. So I need to go look back at some other code. But maybe that would be possible. I don't know. I'm going to leave a comment out. Maybe I'll come back and check it out later. But I would have to put that trait on the breakfast struct. But I just forget how to put traits on things. Okay, here we go. Thank you. All right, so now we have defaults for everything. So technically, maybe we could do it. Let's see, what does this say? Cannot find struct variant or union type breakfast in the scope. Not found in the scope, yeah. So we can't do it. Can't do it. Maybe we'd have to do, or maybe we could do like let mute thing equals back of house breakfast, like that. Nope, still private. Still private. So it's saying seasonal fruit of struck back of house breakfast is private field. Seasonal fruit is private. So even with the default, and the default is where the error is being thrown, right? So the default, you would think the default might be able to give it like some value or whatever, but it can't even do that, right? So we're even stopped from doing that. That was interesting though. Gets me used to traits and gets me used to at least thinking about how things might work. All right, there we go. So we went over this. There's one more situation involving pub that we haven't covered, and that is our last module system feature, the use keyword. We'll cover use by itself first, and then we'll show you how to combine pub and use. All right. So this is going to be, okay, and what do we got here? This is 7.4, then we have 7.5. Yeah, it's a pretty short section. There isn't really a whole lot to really go over here, but this is kind of important because this is how you're going to really like architect your code and make sure that it doesn't look like garbage, right? And then it's like people can show up and they understand what's going on. So you have like properly named modules, properly named functions, and your code structured in such a way that somebody else actually wants to participate. All right, so bringing paths into scope with the use keyword. Okay, that's staying there. It might seem like the paths we've written to call functions so far are inconveniently long and repetitive. For example, in listing 7.7, whether we chose the absolute or relative path to add to waitlist function, every time we wanted to call add to waitlist, we had to specify front of house and hosting too. Fortunately, there's a way to simplify this process. We can create a shortcut to a path with the use keyword once, then we use the shorter name everywhere, else in the scope. Okay. Right, so like for instance here, like I have to do this. Like I don't know if I can really get away with this. Maybe, like you would use like back of house, and then maybe you could get, I don't know. Let's see. So let's grab this code. All right, so we have this thing is mod front of house, and it is in the root crate. Then inside of it has a public module called hosting and a public function inside of there called add to waitlist. We can do use crate, which is, you know, where we are right. Okay, VE is what I want. So crate, which is where we are right now. Then we have front of house, which is this guy up here. And then inside of there, we have our last public module called hosting. And from here now, we don't have to specify the relative path to hosting, and we don't have to specify the absolute path either. So yeah, so I wonder if actually we got rid of this. Yeah, we're still okay because front of house is right here with us. All right, so that's how we can use. That's pretty simple. Now what do we got? All right, this failed, and let's see why. What did we do to have this fail? Unused import, crate front of house, hosting. And the reason is because we need front of house. Yeah, so we need this. I think. No? Oh, wait. What am I talking about? No, we have hosting. One second. What am I missing here? Failed to resolve use of undeclared crate or module hosting. Use of undeclared crate or module hosting. I feel like I'm in one of those. All right, what do we have before? What is the difference here? I'm trying to like suss out the difference. All right, we have our mod front of house. This thing is probably gonna be a pain. All right, we have our module front of house. And then we have hosting inside of it. They're both public. And then we have a public method. In this case, we're using crate front of house hosting. Oh, okay. I didn't notice. They put another module. They wrapped another module around it. I was like, what is going on here? Okay, so now with our module wrapped around it, hosting fails. So how do we get that? Oh, I think I might know a way. Yeah, there we go. We can use super. That's one way to do it. I don't know if there's another way to do it, but super works. Even if it wasn't impl and breakfast, you could construct modify private prop if you will be in the same module. Yeah, if we were in the same module, that's why the implementation has access, right? But we weren't in the same module. Uses are scoped too. Oh, right. So this is at crate scope. So if we use inside of this scope, right? And now if we get rid of super, then we're good to go. Now, if we got rid of the absolute scope, we're going to fail because we have no context outside of the module that we're currently in. Or what if we did super here? See, we could also do super there as well. That would be another thing that we could do because super, basically to me, super reads ... / That's how I read super. All right, I get it. I get it. What do we got in this code snippet? Now, we just get add to waitlist the function. So we can actually pull the function out and just use the function without any like namespace on it or whatever, right? Like we don't need to do like hosting like that, right? And we actually can't because we didn't use anything that way. So there we go. All right, that's simple. Let's try with a hash map now. So now we're using from the standard library collections, and we want to pull in a hash map. And then in main, we're going to say we're going to create a mutable map, and we're going to new up a new hash map. By default, I guess hash maps by default have they're in 32 by default. Can you do, where do we do this at? Here, and then can I do something like string and, well, actually, would I have to do it like this? Like that? I forget. And then what, like U32? Can I try like U32 in here? I'm doing something stupid. But that's all right. I'll figure it out later. Anyway, so now we have map.insert, so 1 and 2, whatever. Pretty simple. Pretty simple stuff, just pulling something from the standard library. Try changing insert and watch types on line 4. What, like in here? I wonder if I do like let mute map equals hash map. None of my coding AIs have any suggestions for me. Okay, so now we got that. There's no strong reason behind. All right, what are we talking about with it? Bringing hash map into scope in an idiomatic way. There's no strong reason behind this idiom. It's just the convention that has emerged, and folks have gotten used to reading and writing Rust code this way. The exception to this idiom is if we're bringing two items with the same name into scope with use statements, because Rust doesn't allow that. Obviously, I mean, how would you? Anyway, listing 7-15 shows how to bring two result types into scope that have the same name but different parent modules and how to refer to them. Okay, so this is the way we'd be able to do that. So both the standard in the standard library. What's the problem here? we're just not returning anything. So in the standard library, we have both FMT, which I'm assuming stands for format, and then we have IO, which stands for input output. And so they both have a result associated with them. Now, if we go like this, we get rid of that, and like this. And then if we went like this and did result, right? That'll fix that. This one is special because of that's how the IO one works, right? So now the IO one just isn't there at all. But there's no way that we could like bring in result and result like that. I was kind of hoping it'll fail. Yeah, it'll even fail here. So yeah. So I'm glad it fails like immediately. 7 chapters already. Wow, this is going to be a hell of a Rust tutorial. Yeah. Well, it's mostly for me. Change types you insert. Try changing insert and watch types on line 4. I don't know. Well, I'm gonna have to get there because I don't know. Like I just don't know how to type a hash map right now with Rust. I know how to like do it in other languages, but not with Rust. I guess maybe we'll find that out later. Just Rust can infer the type from the first map. Oh, that's what you're saying. Okay, now we're back over here. 1 second, I'm gonna reopen this. Now we're back over here, and we have this. So now we have the hash map in 32 and 32 and the key value. So you're saying like if I go in here, whoops, and I put like an A. Okay. See how it's inferring all the way back up there? It even knows, right? So there we go. All right. Thank you for that. I don't always get everything like right away. I wonder if I do. Can I do like? I wonder if it like converts it string from. And then if I pass like ASDF like that. Yeah, it'll even convert it and let me know that we have a string. All right, neat. Thank you. Thank you for being patient with me. All right. Now, providing new names with the as keyword. Okay, this is something I know from Python. I don't think I've ever used this as concept in any other language that I can think of. Only Python, and I guess now Rust. All right, so now we've got a function, and we're doing this as result. Oh, okay, this is nice, because then we can pull this one in as IO result, and then there's no confliction. All right, I like that. Re-exporting names with pub use. I'm skipping over a little bit of the text in the book right now because this stuff is like, we don't really need the verbose description. Like I think you can see that and just kind of get it, right? Now we have this public use. Okay, so this is something a little bit different where I think actually reading it might actually be beneficial. So when we bring a name into scope with the use keyword, the name available in the new scope is private. Okay. To enable the code that calls our code to refer to that name as if it had been defined in that code scope, we can combine pub and use. This technique is called re-exporting because we're bringing an item into scope but also making the item available to others who want to bring it into scope. Right. So I guess you could bring hosting into scope in another module somewhere, like outside of this module. Let's see here. So this is hosting. So we're doing public use crate, which is the crate root, which is this file, then front of house, and then hosting. So we're publicly using this. And in this case, it doesn't matter though, right? Like if I do that, we're still good to go. But making this public is making this public for some other module to consume it, I guess. All right. Right, so before this change, external code would have to call the add to waitlist function by using the path, blah, 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 blah. Now, that this pub use has re-exported hosting, it can just do restaurant hosting add to waitlist. Okay. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. For example, in this restaurant metaphor, people running the restaurant think about front of house and back of house, but customers probably don't think about back of house at all, right? So, right. Okay. So, using external packages. All right, now we get to show that cool thing. In Chapter 2, we programmed a guessing game project that used an external package called rand to get random numbers. To use rand in our project, we added this line to the cargo.toml. So let's grab this. Let's go over to the cargo.toml. Oops, and we'll paste that there. And now look at this cool tool. It's letting us know 0.8.5 is the latest. So what we're going to do is do space LA, and then we're going to do update all crates. And boom, now we got the newest stuff. All right, now back to over here. We're adding rand as a dependency. Then we're going to pull it in here. We're just not using secret number. All right, so we're using rand RNG. And then we're letting secret number equal to rand thread RNG gen range. So, like, this is weird to me. Because wouldn't I only have to, like, bring in, like rand? This import is redundant. Okay. Okay, so here we go. No method named genRange found for struct rand prelude thread RNG in the current scope. Items from traits can only be used if the trait is in scope. So we have to bring the RNG trait into scope to use genRange. And this is redundant, so we could probably remove that. And then let's see if we can do a code action on top of this. This is going to say, qualify with rand RNG? That's interesting. I guess that's one way to do it. So we could do rand RNG genRange and then blah, 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 blah. Which is interesting. Now if we set it back again, the easier way, the way that is more familiar to me, is just to import this trait. Did I just import this to the bottom here? What is that noise? That's really weird. Okay. But I would put it at the top. RNG is a trait implementation that adds methods to the thing that thread RNG returns. Oh, okay. So it's not doing anything like to the method itself. It's adding. Okay. So that trait implementation needs to be available. So that it can add methods to the thing that thread RNG returns. Gotcha. And what it returns is whatever genRange returns, I guess, right? Or whatever thread RNG returns, because genRange is the thing that was kind of it had the underline. But anyway, let's read this because this is kind of important. Ran into definitions. We used the use line starting with the crate. Okay, recall from generating numbers. We brought the RNG trait into scope and called the rand thread RNG function. Members of the Rust community have made many packages available at crates.io, and pulling any of them into your package involves these same steps. Listing them in your package's cargo.toml file and using use to bring items from their crates into scope. Note that the standard library is also a crate that's external to our package because the standard library is shipped with the Rust language. We don't need to change cargo.toml to use std. But we need to refer to it with use to bring items from there into our package's scope. For example, with hashmap, we would use this line. Right, well, we did that earlier. Okay, absolute path to std and the name of the standard library crate. Okay. Using nested paths to clean up large use lists. Okay. If we're using multiple items to find in the same crate or same module listing, each item on its own line can take up a lot of vertical space in our files. Yeah. So this person has written Java before. For example, these two use statements we had in the guessing game in listing 2-4 bring items from std into scope. So yeah, if you've ever written Java, you can see like how out of hand something like importing a bunch of stuff here at the top can get. What are you complaining about? Mismatch types. Did we never parse it? We never parsed it. So this is some old code before we ended up actually writing the parsing logic. Let me read this first. In Rust, you can add more methods and trait interface implementations arbitrarily instead of once in a single class implementation as in Java and basically any other traditional language. Yeah, that's some weirdness that I'm going to have to get used to. So that's what fuels use RNG thing. Okay. All right. Instead, we can use nested paths. Ah. So instead of this, we can do this. It's probably going to tell us we already imported them. That's kind of nice. So we don't have to, do that every single time. We can just say like, all right, from the standard library, give me ordering and give me IO. I like that. Big fan of that. Big fan of that. We can use nested paths at any level in a path, which is useful when combining two use statements that share a subpath. For example, 7-19 shows two use statements, one that brings in standard IO into scope and the other one brings in write. Okay. And then this, self. So this lets us bring in IO, which is referencing self, and then also give me write. That's also nice. And that's like, it's like expected. This is like something I would expect I'd be able to do. The glob operator. The glob operator. If we want to bring in all public items defined in the path into scope, we can specify that path by the star or glob operator. All right. You should probably be familiar with that one. Basically, it'll just bring in all collections. This use statement brings all public items defined in standard collections into the current scope. Be careful when using the glob operator. Glob can make it harder to tell what names are in scope and where a name used in your program was defined. The glob operator is often used when testing to bring everything under test into the test module. We'll talk about how we write tests in Chapter 11. The glob operator is also sometimes used as part of the prelude pattern. Sure. All right, I think this is the last chapter here, not too big, or section in this chapter. Separating modules into different files. So far, all the examples in this chapter have defined multiple modules in one file. When modules get large, you might want to move their definitions to a separate file to make the code easier to navigate. For example, let's start from the code in listing 7-17 and extract modules into files instead of having all the modules defined in the crate root. In this case, the crate root is librs, but this procedure also works with binary crates whose crate root is that. All right. I don't really have that code still, as far as I know. Where am I right now? I'm in this. All right, so I'm still in librs. So we're going to extract some code here. Let's see. We've got this mod front of house, and we've got this. What's the problem? We don't have hosting anymore. And then this thing, also we're trying to import it, I'm assuming. So this is how we have it set up, but we need to create some more files. Declaring the front of house module, whose body, blah, 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 okay. Next, place the code that was in curly brackets into the new file named source front of house.rs. Source and front of house.rs. Now we're going to take this, and we kind of did this with the vegetable garden thing earlier. All right, and that's basically all we needed to do. So now we have the front RS public module that has hosting inside of it and a public function called add to waitlist inside of it. Now we pull that module in here. If we don't do that, then front of house is not available to us. So anyway, we pull it in, and then we have access to public hosting, and also then we have access to the public method add to waitlist. Contents, all right, let's see. What's up, Saeed? Joshua, thank you for the NeoVim from Scratch series. Yep, no problem. Side question, have you tried the Helix editor? I've tried it, but I don't plan to ever, well, I won't say ever. Maybe I'll use it in the future, but right now it's just not mature enough for me to use. All right, so note that you only need to load the contents of the file using a mod declaration once somewhere in your module tree. Once the compiler knows the file is part of the project and knows where in the module tree the code resides because of where you've put the mod statement, other files in your project should refer to the code in that file using a path to where it was declared as covered in that. Okay. In other words, mod is not an include operation that other programming languages have. All right. Next, we'll extract the hosting module to its own file as well. This process is a bit different because hosting is a child module front of house. All right, so I'm not even going to look, and I think what we should be able to do then is front of house, can't spell house. We're going to make a directory. And then inside of this directory, I guess we could make hosting.rs. And then we got this hosting logic here. Now, the same way that in librs we just do that, we should just be able to do that. Right? Now this is saying now add to waitlist is missing, but if we go in here and then we just go like this, there we go. So now we have it all working. All right, I wanted to make sure I could do that without looking at anything because that means that I actually understand what's going on. Just installed it last week and I agree, not mature enough. Yeah, I don't know. I played around with it. It was neat, but it's not there yet, you know? Why everybody is so interested in this new Helix thing. It's basically inventing a wheel in every sense for no reason, in my opinion. Well, you do understand that it's written in Rust, right? So that's what makes it special and different. No, I don't know. Everything needs to be rewritten in Rust for the most part. It feels like one reason I guess you could say that it's nice is because I don't know. I don't know. I don't really get it right now. It has some features not present in Vim. Maybe it's taken from like a lot of, like you could see like how, okay, if you get to a point where a project has become so slow and bloated and bad things and bad code practices have happened in it, like Vim, then someone goes, all right, screw this noise. I'm just going to fork the project and do my own thing. Now, if in your mind it was completely irrecoverable and there was no way that you could even fork the project to make it better, clean it up, and, you know, support your own fork of it, then maybe you might just say, screw it, I'm just going to rewrite the whole thing. Rust is a new language, it's cool, whatever. That's all I really got. I guess it is, yeah, but everything can have multiple cursors. It's not like NeoVim can't have multiple cursors. The features aren't necessarily the interesting part of the Helix editor. It's like the base of what the Helix editor is. Like, why does it need to exist, right? I don't know. Again, it's written in Rust. That's why it needs to exist, right? Just because everything needs to be rewritten in Rust by the cult of Rust. I've been learning Rust by going through Helix source code from the very first commit to the last. That's interesting. All right, so let's continue here. I think I got that. We got all that. We figured that out. I basically just showed you guys how to do it. I don't need to read that. You can go read that from the book, but you watch me factor it out so that it works correctly. So yeah, feel good about that. Alternate file paths. This section covered the most idiomatic file paths the Rust compiler uses, but an older file path is also still supported. For a module named front of house declared in the crate root, the compiler will look for modules code in source front, which we covered, and then this. Oh, okay, so this is old. Good. I'd like to know what's old, because I noticed that they gave us these two options earlier on in the book, and I'm like, all right, am I just going to see some mixture between like whatever, and there's no like standard idiomatic way to do things, and it's just going to be a mess? Or does this mod thing actually provide anything useful, really? But it looks like this is the new, better way. This is kind of the way that you want to do it, and this is kind of legacy. For a module named hosting that is a submodule front of house, the compiler will look for a module's code in this, which is what I just thought to do, and then also this. Okay. If you use both for the same module, you'll get a compiler error. Sure, that makes sense. The main downside to the style that uses file named with mod.rs is that your project can end up with many files named mod. Yeah. That was obviously a poor design decision made by somebody, because that's like having a million init.luas or something like that, right? Like that's not good at all. So I'm glad we're moving away from this, because it'll be like if you like go to find a file and you're like, oh yeah, give me mod.rs. It's like you have like 50 things named mod.rs. Would be a banger if they just rewritten NeoVim in Rust, in part at least, but instead they're trying to reinvent their own foreign thing with visual mode by default or something. Yeah, that's also something I noticed, that it has like visual mode by default. I don't know. Every now and then I'll open it up like on stream, which is the only times I ever open up Helix. And yeah, I don't know, like, I guess, is this in visual mode? Like if I just pressed X, I don't know. I guess X does like the whole, I don't know. This is Rust related, so I get to play around with it in the stream. Moving each module's code to a separate file is now complete, and the module tree remains the same. The function calls in eat at restaurant will work without any modification, even though the definitions live in different files. This technique lets you move modules to new files as they grow in size. Note that the pub use crate front of house hosting statement in source lib.rs also hasn't changed, nor does use have any impact on what files are compiled as part of the crate. A mod keyword declares modules, and Rust looks in a file with the same name as the module for the code that goes into the module. Fair enough. In my opinion, if you just commit the motions to muscle memory, visual mode becomes less useful. Maybe. Well, yeah, of course, right? Like, for instance, you might say, like, all right, I want to change this word. And so you might think visual mode C, right? But if you know, like an operator and a motion, like if you know, what would I call this? Like it's like a motion. If you can operate on a motion instead of going into visual mode, right? We can just do CW, and then we've operated on the word motion, right? So it's better than just doing that in C, where we can just do CW or DW or anything like that. Visual mode's good for other things, though. Like multi-line visual mode is certainly useful, unless you want to count or something like that. But I'm not big on count. I don't ever want to count. Counting is something, maybe some people like to count. I don't want to count. That's why I like things like this, where I can like jump to a word like that. Because I don't want to count. I like the idea of verb-noun methodology in Helix. It's more intuitive. Maybe. All right, well, this isn't a debate about Helix. Rust lets you split a package. All right, we're going to do the summary here. Rust lets you split a package into multiple crates and a crate into modules, so you can refer to items defined in a module from another module. You can do this by specifying absolute or relative paths, so we went over that. These paths can be brought into scope with a use statement, so you can use a shorter path for multiple uses of the item. Yeah, that was nice. Module code is private by default, but you can make definitions public by adding the pub keyword. Yes. In the next chapter, we'll take a look at some collection data structures in the standard library that you can use in your neatly organized code. Now we'll have neatly organized code. So next, I guess we're going to be taking a look at collections. I'm almost certainly not going to do that right now. Yeah, it's big enough to where I'm not going to do that right this second. I'll do this tomorrow. Right. Looks like we're going to do like hash maps and all that kind of good stuff. It should be pretty simple. It's just going to go over basic data structures, I guess. In Vim, it's noun verb, which is counterintuitive. CW, the W part, is called the text object. Right. Yeah, because the word is a text object. Yes. Well, you're getting a little mixed up here, I think. But anyway. All right, so maybe we'll do another stream about Helix or something like that in the future. But for now, we're going to try to stay focused. We're going to get through this Rust book. Then I'm going to just learn Rust. I'm going to learn Rust like I'm really learning a programming language, not like bullshitting it. Like I'm going to try to like go through this book. Then I'm going to work on a couple projects as I get through halfway through and the end of the book. Then I have some other ideas. I might go through Rustlings too at some point just for fun. Thinking about implementing like a few data structures and things like that with Rust just to get some more practice with the language and then brush up on those things. Maybe try out like LeetCode with the Rust. But mostly I want to get the 2 project ideas I have done first. I think that's a better use of my time. All right, so that's pretty much the stream on this. Yeah, it was pretty interesting. Now we know how to use modules and different files and stuff like that. So let me go through some of my stuff, where you can find me, where you can find information about the channel, all that kind of good stuff. You can head over to chris@machine.com. This is where you'll find all of my articles and stuff. I recently reposted all of my NeoVim, the old legacy NeoVim articles. So if you have been looking for those, they're there now. You got links to all my socials here. So you got links to GitHub, obviously YouTube, Twitter @chris@machine, the Discord if you want to talk more about stuff tech related, Rust related, Vim related, Linux related. You can check out the Discord. Patreon and sponsor. So if you want to support the channel, then you can support me either over on Patreon or sponsor me on GitHub. I guess this is one of my patrons right here. Thank you very much, Joshua Taylor. I need to set up a thing where I set up like an ending screen where it says like all the patrons. I got to do that at some point. But if you are a patron, thank you very much. But yeah, you can support the channel there. These are some projects, and again, this is just like the blog, so sometimes I post interesting stuff here. Anyway, that's pretty much it for this stream. Make sure to like and subscribe. Make sure to leave a comment or something like that, and I will see you guys in the next one.